Uh, well, yes, I was. This is again a very important part of your driver exception responses and codes. Imagine you made a mistake. You were asking for a memory which value of the memory which doesn't exist in the slave device. Then the slave device has to have to give you a response saying that hey, uh, you're making a mistake. Well, protocols have very small. They can't really send you all the characters. Hey, itchy boy. Hey, you made a mistake. Instead, they'll send you and some indication. And how do they really do it? Is that imagine you fired this query, okay, and so if the query was successful, so they'll echo the function number. So if the query had no problems whatsoever, then the slave would or the PLC would give you a reply. Since this is a 01 hex 01 query, slave will in the response label send this number 01. So if you, while receiving the response over your serial port and you realize that your second byte is 01, means the query that you sent was legal. And for some reason, if you see this value is not 01 and it is 81, you know it's got 80 added to it. Remember, this is hex and this is also hex, so 81 hex, I mean not 80 in a decimal system, hex 81. So instead you see that you gave the function 01 and in the second byte turns out to be an 81, means you made a mistake. And what mistake? Aha, we'll see. We'll see. Actually, response will have error responses will have these numbers added to it. So if they are like the error response is 01, means the in the query, in the software query, in the packet you send to the PLC, the function number was illegal. So in that case, device will give you a response code 01. 02 means illegal data address. I mean, you were asking for a memory address which doesn't exist, which is outside the memory map of outside the Modbus memory map of the device. 03 is illegal data value. Probably your data type is not correct. Maybe the device is expecting a float value and you're trying to write a decimal to it, or maybe something else. You're trying to write an 8-bit value to an 16-bit register, something like that. 4 is slave device failure. I don't know. I've never seen this error. Acknowledge it is okay. This is an ACK. Slave device busy. Yeah, I have seen it once. Some device would have this implemented. So negative acknowledge that I'm too busy. Memory parity error. I never saw that. So these are the error responses you got to be careful about. So once you get the same number while inside your response, that means that everything went right. And if you've got a different number, if you've got a if you've got a different number than what you sent, then you've got a problem. And how do you recognize what essentially was the problem? So what the Modbus master does, in this case your PLC would do, is that it will add this 80 to that number. You see that? It will add 80 to that number. Means that you have messed up. So this is, you sent 01 hex, you got, in reply 81, showing that yeah, there's something wrong. And what exactly is wrong? To figure out what exactly is wrong, this is the byte, the third byte you got to be taking a look at. And third byte here is hex 02, and hex 02 means illegal data address. So you fired this query to the PLC respond with this, saying that this one showing there's a problem, and this one really shows what exactly was the problem. So you probably asked for a memory address that was outside the, that probably was not existing. So this is an bird's eye view of the Modbus protocol, and in the next set of videos, I'll try to go through some of my own written documents, which you will find very helpful while writing drivers. Yeah, and that really will help you, because there are few things I think which are not quite covered inside. Inside this uh, official document, or maybe, okay, this is what I wanted to share, that this is how my setup is at this moment. I've got ABB's PLC 07KR51. This is the CPU. This is my laptop. I've got a USB 485 converter which talks to the Modbus port of the PLC, and then I've got 3 digital input or 16 channel, 8 at the top, 8 at the bottom. So for digital inputs, and it also has some digital inputs on the CPU over here. Some of the digital inputs and outputs are there on the CPU itself. Then there are two modules for analog output, sorry, digital output, both 16 channel ones, and then I've got a analog input which has 8 channel on it. So it's in 4 to 20 analog input, and then I've got on the 7th channel, I believe, which is number 8 if you are in uh, because electronic normally devices, they count from 0. So this is the 7th channel on which I've got my 4 to 20 input PT100 input sensor connected to it. So I've got my PT100 device interfaced on analog input channel number 7. This is how the setup looks like. The Gora is SPI bus, and again, I mean, this is a little bit about the Modbus protocol itself. So these are the notes I actually took out when I was young, I would say, while working on some of the systems. I mean, this says that Modbus is a request response system, means your HMI asks questions and PLC replies. ASCII means all characters are available. RTU, you don't have all the characters set. You're just left with only these characters, 0 to 9 and F to F, and it's very easy to work with these numbers. Yeah. Once you have got a little background in electronics, you won't find it difficult. Yeah. This is a typical frame of RTU. ASCII frame, I'm not interested. The first is the function. One thing I've missed. The first one has to be, the address of the device, slave device. And since on this 485 network I've got only one PLC, so by default we number it device 1. Okay, there was I did one application where one PC was talking to about 32 devices, if I could recall correctly. And that I had numbers from 0 to 32, so I was talking to 32 energy meters. Yeah. But in this case, I've just got a PLC which is address 1 all the time. Then these are the and second byte has to be the function. Then you've got a count.